now we have the anomaly data. How we recognize the pattern based on a month period. We use LSTM. This stands for short-term memory. It recognizes and registers store the value for each one of the stages in a time series analysis. So if we are like we are at exact this moment at, if we analyze, it was a value, and then now it's a new value, it's memorize the previous stage and compare with the new one in order to come up with a very correct and precise pattern based on a specific time frame in a time series domain. And that's an example I'm going to show you based on the first MVP we did with an application called ShopZ. ShopZ is a critical application inside of our domain. And we took data from along September, and those were the three most critical metrics in the application. And based on the lower level and the upper level, it detects the orange box as the anomaly. So you can see for each one of the exact times the values of the metrics from September 8th to September 14th. It automatically plot these box as an anomaly and took the three metrics, the data store call counts, the other transaction call count, and the external call counts as the most problematic metrics comparing all the other ones. And in an interview with the ShopZ application owner and the application architect, what they told us is that on between September 11th and September 12th, in which we have this rise in the peak for the data store call counts, they had a very severe move to production process. So that's why this anomaly occurred. And actually, we validated that our anomaly is spotted in the right time, what actually occurred. Most interesting in this example here, this demo, is like September was a quarter end period. And since ShopZ is a critical application, what we thought, we made a hypothesis that in the end of the month, we probably would have a rise in the peaks for most of the metrics. But if you see here, that's not the case actually, because what actually represented the anomaly was the move to production process that they've done, the performance, which varied a lot in the metrics for the application and caused a bottleneck for the users. This is an example in which we are plotting the metrics in a view that technicians can see and actually validate what's occurring in the environment. But in the future, we not just want to provide reliability and reduce the cost, but we want to have all the personas that with different roles seeing this data in a different way. Let's say a manager. For a manager, he or she doesn't want to see these very detailed information about the metrics. It just wants to see a dashboard with highlights that a problem is occurring or maybe a failure is about to occur. So we are in the second iteration for this project, and now we detect anomaly and recognize patterns. And we are training that with more critical apps to see how the model is performing and can generalize to new examples. And afterwards, we want to predict failures and bottlenecks to all the applications that are on Big Sky doing the scalability. We want to scale to all the applications. And let's go back to the theory, doing that, putting things into context. I don't want to scale all the applications without seeing all the servers that it belongs to and compare each one carefully as we've done into the MVP, okay? And at the last stage, we want to provide recommendations based on RCA data and also tickets with previous information about an issue, description and the resolution, and also the change information we have already stored